Hello, everyone. This is Fluke Corporation. Thank you for joining us today. We will get started in just a couple of minutes. We're waiting for the last of our attendees to arrive, so hang tight. Hello, and thank you for joining. We're going to get started in just another minute. All right. Hello, everyone. This is Leah Freeberg from Fluke Excelix, and thanks for joining us today for our best practice webinar. You probably know Fluke is a test tool provider, and you may also know that we produce some of the industry's favorite reliability tools, infrared cameras, vibration meters, but you may not know that most of the measurements collected by our tools now connect to data management software. We've produced a framework we call Fluke Excelix that directly connects maintenance and reliability data from test tools to multiple EAM systems of record, where it can be used for asset management. For that reason, you'll find that this webinar series explores a mixture of reliability and maintenance strategies and practices, as well as technology. And that's why we feature speakers from a variety of expert backgrounds, like today's guests. Before the presentation, we have a few housekeeping items to go over, however. Today's session is being recorded, so the phone lines will be muted to minimize background noise. We will save time after the presentation for attendee questions. You can use the questions feature on GoToWebinar to submit your questions and comments at any time. You don't need to hold on those, so find the questions widget now. At the end of the presentation, I will read your questions to our panelists so they can respond, and then if we don't make it through all the questions, we will respond to them afterward. If you'd like to receive the slides from today's presentation, please let us know during the survey that will appear at the end of today's session. The recorded webinar will be available on excelix.com under the community session. Excellent. All right, that's it for housekeeping, and now for the main event. Today, we're very pleased to have with us Martin Davis of DUNELM Associates and Jim Gavigan of Industrial Insight, who will be presenting today's topic, Industry 4.0 and IIoT drive a new world of maintenance. Having talked with Martin and Jim, I can tell you they have a real passion for applying best practices to make the best use of data. They approach it quite differently, and I'm excited for the presentation. Martin is managing partner of DUNELM Associates. He is a results-driven C-level executive and business leader with extensive experience across manufacturing, consumer goods, food, automotive, transportation industries, delivering value globally in large Fortune 100 companies and privately owned companies. He focuses on high-quality business outcomes which result in customer satisfaction and return on investment. Martin has driven Industry 4.0 and operational intelligence strategy, as well as being CIO for over 10 diverse companies. Jim, on the other hand, is the founder and president of Industrial Insight, a software consulting and integration firm based in St. Augustine, Florida. Industrial Insight focuses on helping large industrial companies proactively use time series data from their production and manufacturing systems for increased efficiency, reliability, productivity, and profitability. Jim has 24 years of experience in manufacturing, and he's worked as a vibration analyst, controls engineer, sales engineer, technical consultant, strategic account manager, manufacturing intelligence consultant, and now he's the chief time series data storyteller. and industrial insight. So they're quite the combination. We have the CIO turned OT, who's Martin, and a data analyst and a root cause investigator in Jim. Good morning, Jim. Hello, Martin. How are you doing?
Great, thanks, Leah. Very pleased to be here.
Jim, do we have you on the line as well?
I was muted. I think I finally figured this out. Yes, I'm here. Thanks. Glad to be here.
Excellent. Well, I think to get started, given your topic, how about we start by putting a poll up for our audience, and then while they're answering the poll, I have a question I'd like to ask. Sound okay?
Sounds great.
All right.
Absolutely.
Hopefully everyone can see the poll open now, and everyone go ahead and click which answer best relates to where you're at. How would you rate your knowledge of Industry 4.0? All right, expert, know the basics, heard of it, not sure. Meanwhile, so Jim and Martin, obviously we're talking today about Industry 4.0, but the question we have to ask is Industry 4.0 coming or is it already here?
I think it really depends who you're going to talk to. Yeah, if you talk to particularly the European side of things, it's far more prevalent in Europe. It's probably more its infancy in North America. I think it depends who you're talking to in the industry. And maybe it's because some of the people I talk to, they talk far more about Industry 4.0. Jim, I think you found a bit different.
Yeah, I think it's coming. I don't think we're anywhere near Industry 4.0 yet in this country, which is where most of our customer base is. I think we got a long way to go, actually.
Yeah, I agree with you. There's definitely a long way to go, yeah.
I love that we have both of your different perspectives here. I'm going to close the poll and share the results. And from this, we can all see that the majority of our participants today have heard of Industry 4.0 and know the basics, but clearly they're here and they'd like to know more. So perfect time to turn it over to the both of you. Take it away.
Sounds good, thanks, Leah. So let's kind of start with a little bit about what is Industry 4.0. So yeah, it's a term that came out of Germany around about 2011, and it was actually the German government that coined the term, and they were looking to improve the competitiveness of German manufacturing industry. And there's a lot of different things that make up Industry 4.0. Yeah, there's a lot of things around automation, around using sensors, different approaches, IoT comes into it. But fundamentally, the basis of it is about using real-time data from your equipment to make information, to make decisions. And those decisions are used to improve your processes. They could be manual decisions, or they could be automated. It could be people doing it, it could be machines deciding. But the fundamentally is about using good data to make decisions. So that's the fundamental of it. And I kind of coined this whole kind of concept of Industry 4.0 plus industrial internet equals competitive advantage. So it's more around a strategy and a philosophy plus technologies, enabling technologies give you that advantage. And there's a lot of different pieces to that, yeah. The kind of strategy and philosophy includes approaches, yeah, Lean and Six Sigma and creating a smart factory, about the use of data operational intelligence, about empowering your workers, that kind of key the people aspect of it. The industrial internet side of things is around those enabling technologies, so everything connected, people, devices, machines, use of IoT devices, use of IoT sensors, wireless IoT sensors to help in there. But using your existing operational data, because IoT is not going to give you everything you need. And use of artificial intelligence and machine learning to give you those analytical tools. And the end result is trying to reduce downtime, trying to improve your OEE, improve the visibility of what's going on in your operation. And that then leads to increased revenue and profitability, which I'm sure your management and your executive team is what they'll be focused on. So that's kind of a high level concept, because people kind of confuse, some people use the terms Industry 4.0 and IoT kind of interchangeably. And I just kind of lay out that framework just as a way of kind of thinking about it in maybe a simpler form. But one thing I will say is IoT or an IIoT, Industrial Internet of Things, is not a silver bullet. There's a lot of vendors out there that will try and sell you a lovely IoT platform and a whole load of nice IoT sensors and try and convince you that buying their platform, buying their tools will give you the end result you're after. They will try and sell you that and sell you a price tag of millions of dollars or whatever else. But what I'm going to say to you, and the theme of some of this here, is IoT is a tool and will help you get some information, but a lot of the other information is going to come from the ways you already get the information, you get the data, and it's a lot easier to get data for legacy equipment from IoT or from remote locations. But the key to the whole of this is getting all of the data you need and getting into one location, such as your data historian. So IoT is not a silver bullet. Okay, so let's talk about kind of an approach to this. And I subscribe to the kind of crawl, walk, run type approach. So start small, build on it. So pick a problematic machine center, an area that you've had some reliability issues with in the past. You've had numerous breakdowns. Pick that, and then look at how do I get some good data from that machine center. Existing kind of forms of data like networked PLCs, information from your DCS if you've got a DCS, or use of wireless IoT sensors if you need to supplement those data sources. But it's not about one data source or another, it's about getting all the data you need, then adding to that data, give it context. So where is the data pulled from? What product is being run? What's the SKU of the product being run? That might come from your MES or come from your ERP. Quality data, what's the quality of the raw materials that are being used? Is there additional MES data that you want to pull in there? What's the temperature today? What's the humidity? Other things like that to give that data context. And then analyze it. What's happened in history for that machine? What's happening now? What patterns are happening in the data? How can you predict future problems? So as a kind of a conceptual approach, start small, get the data, give it context and analyze it. It is as simple as that. So if we take a look at the different approaches to maintenance, and I know most of you on here, you say with his old hat, we know all of this kind of stuff, but you start with the reactive, sorting out the mess after it happens. And a lot of people, majority of people are doing preventative, either time-based or it might be usage-based. So we're going to lubricate once a week, or we're going to lubricate every X hours of runtime. Condition-based maintenance has been around for many years, but numerous people are still not doing condition-based maintenance. And that's using a piece of data to decide when to do your maintenance. It might be a vibration sensor or something else like that, but it's pulling that data. And then you get into the kind of more complex, the more predictive and prescriptive maintenance, which we'll talk a bit more in a second. But all of these results, and you're getting more moving from a manual to an automated to a more autonomous side of things, all of those then drive improved business performance. So you're changing your approaches, your processes, your norms, and you're getting more complex, and you're doing your maintenance when you need it and before a catastrophic problem occurs. So if we dig in a bit more on predictive, so predictive is talking about multiple variables. You're getting different sensor data coming in. You're looking at creating models to predict what is going on and look for patterns in the data that predict failures. And those predictive models might include use of artificial intelligence and machine learning. So this is kind of a more holistic Industry 4.0 type approach. You're using your data, you're using advanced tools to help you decide exactly what maintenance is required, and obviously hopefully reduce your downtime. If we take that to the next level, we talk about prescriptive maintenance. So prescriptive takes that kind of modeling you've done in the predictive, decides what corrective action is required in an automated form, and then creates the order for the parts. It issues the work order of exactly what the repair is needed. So you're not sending someone down to investigate a strange reading that might have been thrown out by a sensor, which could be a sensor problem. It doesn't necessarily have to be a thing. You're actually investigating something that a series of sensors have said, yes, you definitely have a problem, and we can diagnose that automatically this is the type of problem, and here's the actions you need to take. So you're getting very much into those more automated and more autonomous type systems. There's more advanced form of maintenance. So into another poll question. Leah, did you want to take over for a second?
Indeed, I can do that. I'm going to launch this one on screen so that everyone can participate. What level of maintenance does your organization use, given that you've just given us that sort of run through? Are you running mostly preventative, condition-based, predictive, or prescriptive? And I can imagine that you might be doing more than one, but do your best to select the one that is most representative. And we'll give you a minute or so here to.
And I think a number of these types of different advanced forms of maintenance have been around for numerous years. But we still see a lot of companies that are in the kind of preventative, and they dabble in the condition-based maintenance, but they're not doing a lot in the more advanced forms. So I'm going to be really interested to see the results of the poll and see what's happening with the audience that's here today.
Yeah,
well, I'm going to close the poll now and share it. There you go.
Yep, as I would have predicted. Actually, I'm surprised at how many are doing predictive and prescriptive.
It's pretty great. Yeah. That's impressive. That's great. All right, I'm going to hide this and return it over to you.
Okay, thanks, Leah. Yeah, so it's going to quite impressive results, and it's great to see that kind of migration into the upper forms of maintenance is happening. So this is a fairly standard type picture, and I think most of you have seen this type of picture before. But the early detection equals reduced costs. Yeah, if you're using techniques like oil analysis or ultrasonic, yeah, it gives you that early warning. And if you look at the blue line, look at what happens to the energy usage as you get closer to failure, and look what happens to the cost of repair. Yeah, I came across an example a couple of years back where the company was doing vibration analysis. They had the specialist team that came and did a vibration report. Unfortunately, the engineers weren't that diligent in actually reviewing the report and looking at what the issues were, which was unfortunate because they had a catastrophic failure, and what would have been a $10,000 bearing replacement turned into $250,000 major rebuild, and repair. So, yeah, as you can see, as that line goes kind of far more towards the vertical as you get far closer to the failure point. So there's a very good economic reasons for actually doing those higher end type maintenance, that doing those oil analysis, ultrasonic, and other things like that. And this is all kind of plays into that Industry 4.0 philosophy, which is saying about, okay, how do we actually organize so that we use our data to make the right decisions to have the most efficiency? And if you're not having catastrophic failures and you're catching those problems earlier, you are then, you're reducing the cost, you're making it efficient, you're reducing the amount of unplanned downtime. And those things is what really drives that bottom line for your company. So detect early, resolve quickly. So the ultimate goal is what I'd like to call real-time machine health. Yeah, we talked about data plus context equals information, but I'll throw an extra one in there, which is maintenance plus information equals savings. Yeah, you're avoiding that unplanned downtime. You're generating a lot of good uptime, additional runtime that you can actually use those machines, which is improving your bottom line. So at this point, hand over to Jim.
Yep, and if you'll give me control, so that way I can control
there you go, you have control.
Thank you. So appreciate you guys inviting me to this. So I want to actually go through some use cases that we both have been working on and have actually worked on in the past. So a little mix of things we're currently working on versus things that we've already done. So the first one, and again, this is the crawl, walk, run philosophy, right? We're going to start simple. So this is one we're doing right now. We have a project that we're working on with a customer where it's more in the preventive realm. We're just going to take runtime hours. We're going to pipe it to their historian system, which in this case is the OSS off PI system. Once a day, we're going to take that out of the PI system as a CSV file and pipe it into their Maximo system. We had some pretty lengthy discussions with their Maximo team, and they felt like to get started, they already had some routines that could process a CSV file. So they said, hey, if we're going to start simple, this is what simple looks like. Now, what we've also done is we've also talked with them about something that could be more complex, right? So this is actually, you know, writing a bi-directional interface to PI from Maximo and, you know, vice versa. And really what we're trying to do is take a more of an industry 4.0 strategy approach with the data and the information that they already own. Well, we've also started talking about, okay, well, we can take the run hours and use that from a preventive standpoint. But what if they don't have vibration sensors? Then what we might want to do is put in a wireless gateway or some wireless sensors, maybe an ultrasonic sensor that gets us the bearing frequencies that we need, that we're really concerned about, and, you know, pipe that into their PI system, get temperature out of the motor, get current, which they likely have now, and maybe even we write some calculations. And come on, there we go. And maybe even write some calculations that allow us to, you know, really figure out what is going on with that piece of equipment. What we've also figured out is that we can drive different work orders based on what the triggering conditions are. So we can write one work order for, you know, runtime hours. Maybe it drives a lubrication or some other kind of a preventive type, you know, maintenance, you know, issue. But maybe if there's a combination of the ultrasonic sensor and the temperature sensor, you know, maybe that drives a completely different workflow, you know, in the Maximo system or in their CMMS. And this can be done pretty much, you know, you don't have to have Maximo, you don't necessarily have to have PI. It can be done probably with your historian and with your CMMS system as it stands today. There's probably a way to do that. So the second use case, this one, I'm actually going to have some words of caution with you as well, because this also was one where the customer didn't take the action that I felt like they should. So we had built a condition-based maintenance demo, you know, kind of a very basic demo, and the customer said, hey, we really like that. Can you do that with some of our equipment? So we started looking around, and I noticed that these loadout screws were drawing more current than they should have been. And if you'll notice, you know, we get up to about 212 amps on loadout screw A, and that's going to be an important piece of information. So I actually was the automation engineer that started these particular loadout screws. I remember actually writing the PLC code that got these things going. And I said, you know, I don't remember that motor being that big. So check the drawings. I said, you know, well, what's the maximum rating of that screw feeder? Well, it's 125 horsepower, 155 amps. 212 is a lot more than 155. So, okay, this is definitely a problem. So this particular plant was getting fed from 3 different other plants within their system. And, you know, as a feedstock, well, plant A's feedstock was very much like what Martin deals with in the wintertime. He has wet, heavy snow sometimes that he has to shovel. And instead of it being kind of a dry, powdery snow, it can cause more problems. And I knew plant A had caused problems in the past because it was like shoveling wet, heavy snow. It's very difficult to convey and move. So I asked the question of them the next day. I said, were you running plant A yesterday when I saw this? Sure enough, they were. So then I asked the question, I wonder if that is going on with feedstock from both plant B and plant C. Oh, guess what? We'll see about that here in just a minute. So then I asked them the question. I said, hey, does this motor have a record of premature failure? Their answer, we think so. We're pretty sure it failed within the last year, but we need to get some more information on the failure history. And this is where the caution starts to come in. They never actually gave me the failure history on this motor. And my suspicion is we probably could have predicted a failure, but we'll talk a little bit more about that here in a minute. So one of the things that the Pi system gives us, and several of the historians out on the market today give us this capability, is to generate an event in the system. So what I wanted to know was tell me every time we violate the 155 amp threshold, and then so I want to start a bookmark of the data whenever I violate that limit, and then when I come back down below that limit, then I want to close that event, so that way I have a bookmark in how long it lasted. And there's also on here a start trigger true for 20 seconds. Well, the reason I did that was this was an across the line starter, and you had inrush current that you had to deal with. So I didn't want to pick that up as an event because I'm expecting that behavior. What I was really caring about is when they're running, does it actually go over, and how often does this happen? So from there, we were actually able to take all of the events and take a look at a couple of things. And a couple of things really stood out to me. One was that 212 number that we saw happened pretty much every time, and it was always that number. And I said, well, as an automation engineer, your current transformer is probably pegged out. This problem is probably worse than what we even suspect. This motor is probably actually drawing more current than what you think. So this is definitely not a good condition. So I said, hey, you need to have your electricians go check that and make sure that that is in fact real, that we're actually getting good data that that's true. In the box on the left, you see that this happens a lot more with load out screw A than screw B. So that was kind of an interesting find. It was what I would have suspected, but it was nice to actually have the data to show that. Okay, now we actually looked at plant A, B, and C. So if you look at that, I guess the fourth trend down, you will see that plant A and plant B, that's the blue line, goes over the red line, which is the full load amps of the motor, and it pegs out as we see at that 212 amps. And so plant A and plant B have that same behavior. And if you look, there's a little spike on the front end of each one of those blue trends. That is the inrush current that I did not want to capture as an event in the system. Now, if you look on the right, plant C never hit those limits. So that prompted a couple of questions from me to them. And this is something I believe you guys can do if you have the data and you start to use it proactively. You can start asking the right questions. So two questions I asked was, one, can you talk to plant A and plant B and have them talk to plant C and figure out what's different in their process that gives you guys better feedstock so that you don't kill your equipment. And oh, by the way, it wasn't just the load out motors that this happened on, it was also their mixers and every other, piece of equipment that was moving this material around. So this was very hard on their system. The other thing that I said is, if you can't change the process, well, then maybe you need to bump up what you're doing, bump up the motor sizes, in your plant to accommodate, this condition.
And I think it's an important point there is when you look at it from a more kind of holistic industry 4.0 approach is look at what are some of the maximums that different pieces of equipment should be operating at, and set events so that you get a notification triggered if you're hitting those limits, so you then know to start investigating further.
Yep, absolutely. So absolutely. So I mean, just remember this: we're taking data they already owned, right? And we're just using it in a different way. We're using it more strategically. All right. So, whoops, let me back up. Maybe previous slide. Okay. So the final thing that we did is, to get to more of a condition-based maintenance type of approach, the analogy I always use is I drive a Toyota Tundra pickup truck. I live in Florida, so most of my driving is on flat roads. I drive on the interstate a lot at cruise control. So if I drive 5,000 miles, most of it's on I-95 on cruise control on flat Florida roads. That's one set of conditions for my engine and my transmission. Now, if I lived in San Francisco and I towed a 5,000-pound trailer because I had a handyman business, and so I'm in stop and go traffic, towing up and down hills, and I go 5,000 miles, that's a completely different set of conditions on my engine and my transmission, right? So what I was trying to tell them is we can actually know how hard you're pushing this equipment, and if we have the failure history, maybe there's a pattern in after so many hours of running over our rated current or some combination of runtime plus running over your rated current, we can actually predict a failure. Now, here's where my caution comes in, is we did all of this work and the company actually never took any action. So here's a theory I have on why that happens, and I think this happens a lot, is I think a lot of companies are running very lean, and a lot of people have a fire hose in their hand all day. So they don't have time to step back strategically to think about these kinds of things and, okay, how am I going to use this data? Is this true? Because this is still going to take a little bit of time. You have to put down the fire hose for a little while to sit down and think through, how can I make use of this data? So my caution is, and my encouragement is if someone comes to you or if you come up with something like this, put down the fire hose for a little while, and I believe it's going to pay off for you. So another thing that that we have a partner that's working on this one, and I'll grab some screens from their system. This is a web-based application where they can actually look at, they're in the maintenance game, and they have done tremendous amount of study, as a lot of people have, of what makes rotating pieces of equipment fail. So the failure modes are known. The thresholds generally are known. So what they were able to do is say, hey, if you put these sensors on, here is how confident we are that we can predict a failure in this particular piece of equipment. Now, depending on criticality of the equipment, you may want different coverages and be able to predict different failures, okay? So they actually have a way to kind of analyze that. Well, where does that lead you next? Well, where that leads you next, and back to Martin's point, well, is if you know the thresholds, well, then all of a sudden you can start building displays that are very dynamic, that turn red, turn different colors when you get outside of the normal operating ranges. Now, one of the things you can also do is use augmented reality to actually, as you're looking at either a picture or actual footage of the motor or the piece of equipment that may be having a problem, you can overlay data on it. You can overlay work instructions, videos. We're even hearing the technology is available today where you can essentially have a virtual assistant, someone who is live with you, looking at what you're looking at with the data overlaid, and they can guide you through any kind of repairs potentially.
And I think that this is a vision I have for kind of maintenance of the future, which is, yeah, these kind of easily worn kind of Google Glasses type head-up displays that is overlaying this additional data. So a maintenance guy looking at that piece of equipment can actually get all this extra data, this extra information. He can check the schematics, he can check the parts inventory, whatever else, without actually leaving the machine. And I think that this is now, the tools to do this are actually available right now. And I think it's going to be a while before it gets fully adopted and gets adopted in large numbers. But I think that it's a whole new world of maintenance out there, and I think this is going to change the game.
I agree, and it changes how your partners interact with you as well. If you have a partner that works with you on preventive maintenance, they can essentially be looking at what you're looking at from thousands of miles away. So they don't have to get on a plane and fly to the plant. So I think this is huge potentially. So the last thing I want to talk about is we actually have a customer that has spare pumps. So they have an A pump and a B pump, that back up certain places in their process. And so what they do now, their current situation, is a maintenance technician takes basically a day a month to go around and figure out, has each pump run? Has it run long enough to satisfy our criteria? And what they've asked the plant to do as an experiment, as they believe it'll increase reliability, is in the odd numbered months, like January, March, May, run the A pump. On the even numbered months, February, April, June, etc., run the B pump, because we want to see if this in fact does increase our reliability. And so what they have to do now is the technician takes a day to compile the report. And how does he do it? Goes back and looks in their plant historian to see if the motor has run. There are actually motors that are pumps that are not in their historian. So he has to physically walk the plant down and find out if they're running. If they're not, he has to go physically talk to the operators and say, what's the scoop? Have you run it? and take their word for it. So there's a couple of things at work here. Is from an Industry 4.0 perspective, strategically you're doing the wrong thing here. From an IIoT perspective, you're doing the wrong thing because you don't have all the data. You're not collecting all the data. So I would very much.
I think you said that this takes the engineer 8 hours every time he has to do it?
8 hours a month, correct. Yep. The other problem that they have is on May the 27th, that we're looking at Area 5 here, this maintenance technician sat down with Area 5 and said, hey, you are very much out of compliance in April. On May 27th, you were out of compliance in April. And they said, well, Chris, in May or in June, you're going to come back and yell at us about May because we're just now talking about this at the end of the month and we don't have a chance to fix it. So this is a complaint not only from the maintenance technician, but also from the areas themselves. They don't even know if they're in compliance. So what we've done, again, is take the data that they already have and start to use it more proactively. So now what we've done is do a few calculations here and there to figure out whether or not the pump has run and run long enough. And we roll these up by area or by a particular part of the plant. So in real time, they can see if they're in compliance or not. So these are the areas, then each area is comprised of units. They can drill down into the units. Then they can drill down into each unit's particular round sheets, and take a look in real time. Has each pump, been running and for how long? And then they can actually switch between them very, very quickly. So in real time, anyone in the plant now can go look at their compliance, and we've taken that 8 hours of manual work and made it where they can sit there and dynamically talk about it and dynamically change their behavior. So again, we just took what they already had and just made it a little bit different. Now from an IIoT perspective, we have some other use cases on pumps where we're going to need to add some sensors. We're probably going to add some either wireless gateways or wireless sensors to those to get some of those use cases done. But again, we started small. We started with something that is a problem, and we're doing the crawl, then the walk, then the run. So in closing, here's some thoughts from the trenches, and I'm going to get a little preachy here. I'm just going to forewarn you. I'm sorry in advance if you feel like I'm pointing the finger at you, but I really feel passionate about this in case you can't tell. So first, need high quality data. That means it's reliable and at the right frequency or fidelity. That means is if I need 10-second data to troubleshoot a problem, I don't need to be collecting that data at 1 minute. Okay, so you have to get the right frequency or fidelity, as we call it, from the right sensors and then actually stay calibrated. What does that mean? Well, we have a customer that has a large piece of equipment that is highly critical to their plant. It costs 6 figures to rebuild about every 18 months. They have some nice sensors on there that don't work. For instance, the outboard bearing temperature on the motor has read 500 degrees Fahrenheit for the last 4 years. They have overall vibration sensors on a different part of the piece of equipment, the driven piece of equipment, that have not worked in 4 years. Well, here's the thing. They may not even have the right sensors because maybe they need ultrasonic sensors that will actually look at the bearing frequencies, because if you pick up something in the overall vibration spectrum, you're probably already too late. You're already on the wrong part of that curve. So here's the thing. You have to have the right sensors. They have to be calibrated, and you have to get them actually into your system at the right rate so you can tell what's going on. Your data historian, likely a gold mine of information. So don't just use it reactively. I always tell our customers, most of which are using the Pi system, is here's what we hear. Hey, something broke. Let's go look in Pi and see what happened. So don't just use it reactively. Your data historian is not just a bunch of trends. As you saw in a couple of my examples today, we were actually taking information, looking at how much time have I spent over this threshold, or what is the roll-up of how many pumps are within compliance, right? That's all historian data that I've just done some analytics on so that it tells you, a little different story, right? That's why I call myself a chief data time series data storyteller, because it has to tell you a story and a bunch of trends typically don't, okay? The integration options with CMMS, augmented reality, machine learning, AI are endless, absolutely endless. You can do anything you want. The technology is there, okay? But back to number one, if you don't have high quality data from the right sensors, don't waste your money on this technology until you do. Give you one caveat to that. Sometimes you have people in your organization that sit at a very high level who think this is what we have to do. Everybody else is doing it. So therefore, if I'm in the maintenance organization, I probably already know I don't have the right sensors or at the right frequency or fidelity. So use that to your advantage and use that to prove, hey, if we're going to do this and we're going to be able to use these tools, this is what we need to be able to do our job well. And we've actually used those kinds of initiatives to drive that conversation back down into the maintenance organization and say, hey, you need to get the right sensors, they need to be calibrated, you need to have a system to keep them there, okay? So if you're not historizing condition data from your equipment, or if you don't have a plan to, go ahead and plan for extinction or irrelevancy, okay? In my opinion, condition-based maintenance and reliability improvements is the single largest opportunity in the industrial Internet of Things or Industry 4.0 initiatives. I just absolutely believe this is the one that we're going to gain the most benefit out of, even over productivity improvements and other things. I think this is the big one, honestly. Okay, so my opinion, get on the train or get run over. Okay, so sorry I had to get a little preachy there, but I just believe in all of that. Okay, so what do we think this can do for you? We think there's this is industry studies. There's a 30% potential reduction in maintenance costs, lots of reduced downtime. So our question is, well, why aren't you doing this right now? Well, sometimes I don't know how to get started, Jim or Martin. So here's a couple of things that tips that we offer. One, put down the fire hose. Find good data from one particular problem area, just like what I did, and I walked through my 4 use cases. Find one thing that you really feel like will pay you back. Figure out what all it is you need to do. Then prove to yourself that this approach actually works. Repeat, and then you'll be able to use the fire hose less often. Okay, but you have to put down the fire hose first. That is step one. If I have to give it to someone. So with that, we have very quickly run through a whole lot of information. So
fantastic work, Jim and Martin. Thank you very, very much. I really appreciate the balance between the use cases as well as the high level thinking, the practices focus of Industry 4.0, and the technology aspect of the industrial Internet of Things, but most of all, the core message that you're probably already collecting indicative data. Slow down, figure it out, adjust your process so you're looking at the data more frequently so that it can do you good ahead of time. That's actually a very reassuring message versus you have to go buy a bunch of things all at once because you're doomed.
I think a lot of people get kind of these big terms of Industry 4.0 and industrial Internet of Things, and you've got these vendors selling these kind of answer to world hunger, and I think when you really start to boil it down, a lot of it is down to approaches, and you can start small. You don't need to go and spend a load of money. You can start small and build on it and actually get good results out of it.
Yeah, I mean, as a for instance, pumps, we have one with a customer that, they have 25 bad actor pumps that rotate through their system. They reevaluate it like once a quarter or twice a year or something. And in most cases, all we know is that the pump is running. That's it, right? And so I said, well, at least you need inlet and outlet pressure and horsepower. And they're like, yeah, then we can figure out where we're operating on the pump curve, right? So you have to put maybe 75 sensors on the 25 pumps. You need 3. You need something to figure out how much you're pulling, how much current you're pulling, and then 2 pressures, right? So it's not like it's this massive need, but the upside is huge because then you can start to understand when a pump is starting to struggle and why. So it doesn't have to be some massive thing. Pick something where it makes sense. If you don't have the instrumentation and data, I mean, literally, you can get it in so much cheaper than you used to be able to. So.
I'll give you another example. One of the plants that I was involved with had 4 large air compressors, and by actually monitoring the actual air pressure in the lines, they discovered various leaks. And after actually sorting out, just simple things like sorting out some leaks of air pressure, compressed air, They found they only actually needed 3 compressors, and they could keep one turned off as a spare. And there's a big saving in kind of the operating cost of the plant by doing that.
No doubt. No doubt.
At this point, I'm going to break in and remind our audience that they are welcome to type in questions. You should see a questions part of your dashboard with a little caret next to it. If you click down that, you can type in your question, and then I'll read them out for Jim and Martin to answer. We've gotten a couple already. And actually, to help answer the first one, could I get either Jim or Martin to scroll up to the PF curve? Because it'll help answer this question, actually. I'm going to read it out while you scroll up to the rainbow, as it were. So the question is, could you please share various IIoT platforms available with Fluke or any other make? And could you also please share details of analytical tools which can be integrated with various controllers of machines? Now, of course, yes, Fluke does have an IIoT platform. It's not the only one out there. But how would you guys go about answering this? What IIoT platforms are available, and what analytical tools can be integrated with various machine controls?
Oh, wow. So how I would start is let's start with what you have, right? I'm a very practical person. I mean, I come from a controls background, and I would start with what do you own today, right? Rather than just throw out a bunch of platforms that, there are a bunch, but I would start, okay, what do you have today? Because in a lot of cases, you can take what you have today and almost turn it into an IIoT platform. And, like some of the things we're doing, from an integration standpoint, is sometimes the data historian can write back down to the control system. We don't typically like to do that. We typically like that to be one-way traffic. But, one of the things that, we've noticed is a lot of times, like let's say someone wants to add an ultrasonic sensor, to pick up bearing frequencies, on a rotating piece of equipment. Well, sometimes there's no IO left in the PLC or DCS, or it's very expensive to add. Well, you can get some gateways that are in the $700 to $1,000 range that you can pick up a couple of analog IO points, a wireless card in it, and all you have to do is drop power and wire your sensors in, and the sensors can be, a couple $100. So, literally you can monitor a very expensive piece of equipment, and get the data into what you already own, for $1,500, $2,000.
Yeah, and I think
so you're a fan of. Oh, sorry. Go ahead, Martin.
No, go on, Lee. Go on.
Oh, I was just gonna say you're a fan of bolt-on sensors. Are there any concerns about then getting kind of a Frankenstein where you have too many data sources and not enough integration?
Yeah, I think that's working. I mean, there's a lot of talk in the IIoT industry and community about some newer protocols. One of the big ones is MQTT. That's M as in Mary, Q, T, T, right? And the idea that's coming, and that I think will eventually kind of win out, is basically you're going to put all of this data out on essentially a data bus, and whatever system of analytical tools you need, or whatever system needs to consume the data, will just be able to plug into the bus and consume the data as it's needed. So I think that is changing. Yeah, that is a concern today, but I think the way things are going with some of the protocols being developed and the technology being developed, and it's already here, I think that's going to go away.
And that's Martin, what were you going to say before I cut you off?
I was just going to say that there's numerous IoT platforms. It seems to be another one thrown in every day. And I'm a fan of looking at how IoT can be used to supplement what you already have, your existing data historians. I used a series of wireless sensors. We were using sensors from Advantech, and we were using some connectors and edge connectors from AspenTech. And this was using a wireless meshed radio network within the plant, dust radio, using MQTT, which Jim just mentioned, to transport the messages from these sensors to the gateway, which then fed directly into your data historian. You didn't need to buy another platform. So this was using IoT sensors, wireless IoT sensors, which were low cost. The sensors were a couple of $100 each. The edge gateway was like $500 or something in that region. And that was then feeding directly into our existing data historian. And that just gives you additional points of information you're pulling from these machines, this legacy equipment or remote locations, which is giving you that extra data you need, and you then combining it with your existing historian to give you a full picture. Because I think one of my biggest concerns is you're going to end up with this Frankenstein, as you said. You end up with, okay, we'll buy some sensors and an IoT platform from vendor X. We'll do something else from vendor Y. You've got your existing historian as well, and you don't have all of the information in one place. Think of the old days of where you brought in an external company to do vibration analysis, and that data is provided to you in an Excel sheet or an Access database or something else, and is not part of your historian. You kind of almost you run the risk of coming into that very same type of situation with IoT. So I would very much kind of advocate trying to get all your data into your existing historian and avoid getting this fragmentation of platforms.
Yeah, Fluke has put a lot of work into making their test tools, as the questioner asked, compatible with Maximo and other EAM systems, so that you're not winding up with so much data in so many places that you can't actually manage your asset data. To the person's question, and you showed us a lot of great examples there. Do you think that there's enough analytical support available then, with if you have the right sensors, putting the right data into the historian? Do you have all the analytics you need there?
I think,
as I said, there is numerous analytical tools out there. There are ones that come bundled with your historian. OSI Soft, which is a massive share of the historian market, has some really good analytical tools. And if you need to go beyond that, you can take it into Tableau or some other normal kind of analytical tool to take it even to the next level. So I think you've got a raft of options, and you're seeing more and more companies coming out with bolt-on platforms which are using machine learning and artificial intelligence to ingest that data from your historian and give you another level of analytics, and more automated analytics form.
Mm-hmm. Well, and here's the reality. Most of rotating equipment failures can be detected with first principles. You don't need an advanced algorithm. You kind of know what a spectrum, if you have an ultrasonic sensor, you know what that spectrum looks like if you need to lubricate, or if you start to have an inner race, bearing problem, or an outer race bearing problem. You kind of know what that looks like and what those thresholds need to be. There's been enough study in rotating equipment. So yeah, I think the analytical tools are out there. No question about it.
We have just a few more minutes, and I want to remind the listeners that there's a survey at the end, and if you answer the survey, you get sent the slide. So hang in there for just a few more minutes, and I have one more question to ask Martin and Jim from the audience. The person writes, I work at a small manufacturing company with a small amount of assets. I would like to use CBM on our most critical assets. Does it make sense to install sensors and systems to collect and interpret the data for, say, 8 pieces of equipment?
Mm-hmm. For me, yes, absolutely, because if they're your critical pieces of equipment, that's how you make money. Now, there's lots of platforms out there. I would definitely look at cost versus capability. Mm-hmm. And those are things, they're, gosh, how do I say this the right way? So the platform that Martin and I have continued to talk about, they're very prevalent, right? But they're also fairly pricey. So there are other systems out there that are less pricey to get into that can still give you a good amount of information, right? So if I'm a smaller manufacturer, I might look at some of the more lower cost platforms. I'm not going to mention any on here, but if you want to email me privately, be glad to point you in a couple of directions there of some things we've looked at that I think we would trust. I wouldn't trust everything, but and that is I'm assuming you have nothing at this point. But if it is critical to your business to get product out the door and that's how you make your money, absolutely, even if it's just 8 assets, it's absolutely going to pay off if you monitor them and start doing condition-based maintenance around them. Absolutely.
And I suppose the other way to look at that question is, do you want to be having downtime where you're running around with the fire hose putting out the fire, or do you want that machine to be running at an optimal level, producing product or whatever it is your business is, as much of that time as possible, which at the end of the day is bottom line to you?
Right.
Well, and if you know the equipment is likely to have a problem and you see a gap in your schedule coming, then you can schedule the downtime and say, hey, we need to make these repairs at this time. Well, if you're not doing the condition-based maintenance approach, then what happens is at a critical time when you need to deliver an order, you don't know that the equipment is on the edge of failure. And so therefore you're running when you really critically need to get product out the door with a machine that, or piece of equipment that's on the edge of failure. I would rather know ahead of time. And it's like, well, if I had known this 2 weeks ago, I would have, when I was down for a week, I could have made that repair. So I think
here's another question for you.
Sure.
They ask, would it make sense to correlate past failures with lost production time so a manufacturer can know and justify additional maintenance equipment and software?
Absolutely.
Absolutely. Great question. Great. Yeah. At the end of the day, yeah, this is how you justify buying the extra tools you might need. Is, yeah, the example I gave earlier of the catastrophic failure cost them $250,000 for a $10,000 repair, or replacement maintenance. If you know and you can correlate previous problems with the cost, all of a sudden you can put that in front of your senior management and say, hey, look, yeah, because we didn't have the data to understand what was going on, it cost you X $1,000. We need to invest some money to avoid this happening in the future.
Yeah,
and with that, go ahead.
I was just going to say, I mean, I gave the example when I got preachy there about the piece of equipment that was several hundred, or 6 figures to repair, and on average 18 months plus it's in a critical area of the plant and it costs downtime, and the vibration and temperature sensors didn't work, right?
You've just answered one of the other questions. Well done.
Yeah, so for me, I'm like, it drove me back to the plant manager that said, hey, are you going to support putting in all of the right sensors and actually getting it in? Because how we actually found that was they wanted to do some testing on some machine learning. Hey, can we use machine learning around the previous failures to figure out if we could have known that was happening? So I built a little dashboard for them, and I look and I'm like, well, heck, some of these sensors haven't worked in years. So now we've kind of missed an opportunity to even use some of the new analytics tools to predict a failure because they didn't have good information to be able to do that. So, but that was the whole justification, right? Was, hey, this costs us 6 figures. It's every 18 months. We know what the downtime is. And I'm like, okay, well, you need to spend some money here because it can justify itself.
In fact, another question that just came in was about tying the data to quality, and I think you just touched on that.
Yeah, we've been doing some of that as well. We were actually doing some statistical quality control, and we were actually capturing events when the quality went out, and we're having the operator feed us back reason codes as to why they felt like things were out. And there was one where the water header pressure was causing a quality issue, and it's something they had kind of known about, the operators had complained about for a long time. And engineering had kind of been like, yeah, you keep saying that, but I don't really see it. Well, then they were able to correlate, hey, here's how often this particular problem actually contributes to a quality problem. And so therefore, then they can make that determination. Okay, well, we've known for a long time we needed to drill a new well. Okay, what's the cost of that versus the cost of the quality issue? So now they can have a legitimate discussion around data. that, you know,
Right.
tells them, okay, does this make sense for us to drill that new well or not? So yeah.
So we have a few more questions, but I think we've really covered most of it in what we've talked about here. And your contact information is up on screen, and I believe I'm correct that anyone listening is welcome to contact you directly, right? If they have questions about what you've talked about.
Yep, there's on my website, there's a contact page, and it goes to info@industrialinsightinc.com. But if you want to bypass that, it's just my first initial, last name at industrialinsightinc.com. So it's Gavigan at industrialinsightinc.com.
And similarly, if you go to my website, DUNELMassociates.com, there's a contact form on there, and feel free. And I'm happy to talk Industry 4.0 and yeah, how you can use your kind of a strategic approach to actually drive more value.
Indeed. And will you scroll down to the slide after this one? There's a little nugget there I want to make sure that people see, because there's a really good session happening in November called Accelerate, where a lot of these same questions are going to be discussed in greater detail. So if you go to Fluke Accelix, you'll find more information about the Accelerate conference happening shortly. And I'm fairly sure that's it for today. Thank you both so much. As I mentioned, when I close things out, a brief survey will be displayed on your screen, and we would greatly appreciate it if you take a few moments to complete it, and then we'll send you the slides. So thanks everyone for joining us. Thanks especially to Jim and Martin. That was fantastic. Loved the conversation. Have a great afternoon, everyone.
Yep, thank you.
Thanks, everybody.
Thanks very much.